Hello, 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 and welcome back to Advent of Code with Cast Day 11. Penguin operator. Okay. Jonah Anderson, Pigorley, hi.
Hello J0 Han Anderson.
And Veldak. How are you guys doing? So, we solved 10 days of Advent of Code already. There is just 2 days left. Almost there. So, I don't know, let's just get started here immediately. Let me first open my project. You'll start with day 1 tomorrow. You will have solved both in Python and XSLT. Hello, Nigel. I guess I'll keep the syntax for the reversed range, maybe. Actually, no. We'll remove that until I need it. Day 11. Let's go. Okay, so what's the thing here? What's the thing that we need to do? There's a server rack, and we have a list of devices and their outputs. So we have device AAA, the output is U and HHH. Seems like we have a graph here. Each line gives the name of the device board while a list of the devices to which its output are attached. So BDE means that device BBB has two outputs, one leading to device DDD and the other one leading to device EEE. The elves are pretty sure that the issue isn't due to any specific device, but rather the issue is triggered by data following some specific path through devices. Data is only ever flows from a device through its output, so it cannot flow backwards. So we have a directed graph is what this means. After dividing up the work, the elves would like you to focus on these devices starting with the one next to you. And we have a label which just says U, so like one of the devices is U. That's our start. And ending with the main output of the reactor, which is labeled out. We have start, we have the end. I need to find every path from U to out. In this example, these are all of the paths. And we need to calculate the amount of different paths, basically, right? Since the amount of different paths is finite, does this mean that the graph does not contain the loops? Because otherwise, we could go through the same loop multiple times and we would consider different paths. So I'm assuming that there is no loops in the given graph. So in order to calculate the amount of different paths, we just need to do dynamic programming on the shortest wait, hold on. It's not necessarily shortest, right? Yeah, just dynamic programming, that's it. We don't even need to calculate the shortest one, right? Okay, this one is really easy. The only problem, the only question is, can my language handle it in terms of performance? input txt. Example. Example is this. All right, let's start by reading the input. So what we will have a graph, right? We'll have a graph. Graph. So graph has the outputs, or I guess like connections. I don't know. Yeah. We just need to have connections. Let's just say we have vertices. So this is the graph. The graph has vertices. So this is going to be just vertex. How about I try to make this thing generic? So we have vertex, then vertex is something like we have the outgoing edges, which is a list of the outgoing edges, which is just going to be a reference to the other vertex, right? So reference to vertex, I guess, is the thing. That would do here. List type shape type is not equal to reference type. What? Oh yes, because this is a type. I see. When you say like type vertex. Can I not even specify this? Interesting. And like, yeah, I need this currently in the current syntax. When do we pivot to hightail streamers? I don't know. I feel like hightail is going to be so like, I don't know. Like, is there a reason to even be streaming it? It might be better in the beginning. Do you mean the game itself or the yeah? I mean, probably. I don't know. That's what they said themselves, right? As far as I understand. Okay, so we have the vertex like this. We have the outgoing edges. And then inside of the vertex, I want to store basically the calculators, you know, like paths to target, right? Which is going to be just an integer, whether we calculated it or not. Yeah. So I want to wait, but vertex is going to be. I need to have a map. I want to have a map from string, right? Which is the which is the name of the vertex, right? So string in this case. Map from string to vertex. Obviously, I don't have maps right now. Let's say what a map is. Map. I'm wondering if That's what I should be doing here. Let's try this. I have been doing this differently. In the are we going to be Hightail Motors? I don't know. I feel like not. I feel like I'm not even sure if I'm going to play it and when it begins. Because I don't know. Like, yeah. I feel like there is a lot of other people who are going to be doing that. No, we have a language to make. I think I should focus on that instead, and the game, the Linksider to be finished, maybe. And Factorio, I guess, is another thing. I don't need. I don't need one more thing in like to be distracting me from like the other things. Linksider can wait. Yeah. You think we should be doing the Hightail? I don't know. We can port Linksider to Hightail minigame. Okay. Are you going to make a mod for Hightail which allows you to write bash in Hightail, Vetcop, or something? Okay, let's just see. Module. I mean map. T is we're just going to have inner is, so I'm going to be using the trips of T's. No, hold on. We have a map has key and value, right? So this is going to be trip T we call it KV or something, right? KV is type where key is K and value is V. Trip TKV. Yeah, I need to do like use std collection strip. Okay. It seems like this is not compiling. Okay, I guess this actually doesn't work right now. I think this doesn't actually work right now. Like, I actually need to do this. Currently, right? So it's going to be still map T string vertex. The bash tail. Okay, so what do I need to do? I need to be able to create a new graph, right? Initialize a graph. Wait, hold on, but this over here seems to be working. Why was the other one not working out when the generics were on the outside? I'm not sure. Anyway, so initialize is a function that will return the graph, which is going to be vertex is map init, right, like that. Init is a function that returns t tkv kv. This just returns inner is strip create. Should I call this all create too? Sure. Let's see. Let's G is graph create, right? Like this. Let's see if this works. Day 11. Okay, so this seems to work for now. So I need to do string lines of the input line. If string length line is 0, then return Okay, so here I need to like parse this thing, right? So first I need to do string split once line using a colon, right? Using a colon. So this is going to be the vertex and outgoing edges, right? Okay. So then we say that string. I need to split out by space. So this is the other vertex. I need to say that if u is string trim u, if string length u is not 0, then I need to like add this vertex, this to the outgoing edges of v, right? Yeah. So I just say that v is v is so I want in the graph to create the vertex if it does not exist yet. Actually, it always exists, right? But not exactly. Like I need to, yeah, because like over here I want to create the thing immediately, I guess. Yeah, I want something like create if it doesn't exist. You know, create the vertex if it doesn't exist. Yes. Let ensure vertex get or init vertex, you know, vertex named name. This is going to give me a reference to graph vertex, I guess. Right? Hello, Devninia. Let's see, const get or init vertex is graph, which is graph. And then initialization function is a function that actually like constructs the new vertex, right? This is going to give me the reference to vertex. That's going to be basically oh wait, and like, and over here the name. Yes. So yeah, graph like name string. Can I like, let's just have the alias here. So vertex ID is string, right? Because that's vertex ID basically. So get or init vertex by the ID, which is vertex ID. Is there any reason why TTS doesn't announce it anymore? I don't know. I don't know why. It's just RNG. Sometimes it doesn't work. I mean, I can try reloading it. Can I see the console errors? Like, and yeah, it actually worked earlier, right? When John Anderson joined.
Hello Dev 9-inch nails ya.
So I clicked this manually. For some reason, it didn't play automatically. I guess. I don't know. I don't know why. Okay, get or init vertex is the function that is implemented like what? I need to find this in the map, right? So I need to in the map get or init, right? So it's literally just map dot get or init.
It's just TTS. It will work if it wants
G dot. It's just TTS. It will work if it wants to. Yeah. G dot vertices. I'm trying to find the vertex ID using the init function if it doesn't exist, right? Yeah, all that. Get or init. Okay, we have it's kind of like the same thing. All of that is like the same thing, right? It's just in this case, this is going to be TKV. The ID is K, I guess, and init is V. Return reference to V. Okay. So what do I do here? I need to say. I need to say. Rip. Dot. Split. Oh wait, I need to also know how to compare these things though generically, which doesn't. Well, I mean, right now it kind of will work. Trip split. G inner. Having a function. Split behavior. I need to say that if data value dot key if key is less than or equal than the key, then I'm kind of like doing the same thing. Hello, Boolean. I think I already said that though, right? But hello. I've already written this previously when I was doing the set, but now it's a map and not a set. But it's kind of like all the same code. We should like generalize over this thing and put this into the standard library somewhere. So this over here is the key, not ID, right? So if key is less than or equal, then data value dot key, right? Then we put this into the left sub, and we split the left subtree. So this belongs to the right subtree, right? So this is going to be once again less and greater or equal parts, right? Otherwise we do the right subtree here. Then we do equal and greater is equal and greater. So I cannot do +1 here though, like I did in the other thing where I was just having a set of integers. In this case, it's a set of strings. So I cannot do +1. But I want, yeah. I feel like maybe I want to change the split here. Let's see. Let's see. Here. If I copy the split from the trips, Follow Ves. Trip T. Trip. T trip T. Trip dot node splitter. Let's call this over here split trip. Maybe like I want something else. Maybe like I want to change this in the standard library. Trip update data. Let's see. Let's just do this in line for now. Like I feel like I want the node splitter. This is the behavior, and the behavior basically tells me, like right now it tells me what should I split, but what I want it to be telling me is like, where does this node belong? Does this node belong to the left subtree, or does this belong to the right subtree? Right? Because otherwise it's a little bit weird. So if this node belongs to the left subtree, it means that I need to split the right subtree. So it's like completely opposite of what it needs to be. Right? Can I just say over here right subtree and over here left subtree? So that is like a little bit more obvious what's happening here. So instead of doing trip split, instead of a dot, I'm just going to use the underscore here. So basically, over here we want less. We want the items that are less strictly. Well, I mean, this is the node. If the node key is less than key, then it belongs to the left subtree now. Otherwise, it belongs to the right subtree. To the right subtree is the things that are greater or equal than key, right? And then over here, if it's less than or equal, right? If this is less than or equal than key, then we do left subtree, otherwise we do the right subtree. So now we have less, great, equal, and greater subtrees, right? Then I do if trip length, of the one that is equal to 0, then it means that I need to construct a new one. So we do equal is a new trip singleton. With the value where we have the key, and value is initialize the value, right? Like this. And then we just merge the stuff back. So we do trip join less trip join equal greater, right? Like so. That should work. I mean, this is my over here I split not that, I split greater or equal. Over here I split the node itself, and over here I say that g.inner is equal to this, but I return the reference to the equal node, right? So I just return equal dot value, right? So equal, so trip dot at equal 0 dot value reference. Is that what I want? I think so. Type shape underscore is not okay. So now if in order to get oriented to a vertex, we just say map. No, we just say graph dot get oriented vertex. Get oriented vertex. The graph. The ID is name, and the initialization is just the vertex. So now it depends what we actually store in the vertex. And over here, I want to not store the vertex, right? This over here is the generic T. So this is the data. The data we store in the vertex is of type T, right? So this init should return T, and over here, in order to initialize, we return the data is the init. But then we also say that paths to target. Well, I mean, isn't paths to target something that is this like generic thing then, right? So just say data and out is list create. Right? That probably makes sense. Do it like this. Okay, so now what do I want? I want get or init vertex here, right? I'm actually like, these references are not stable though, right? Or at least they're not supposed to be. So if I just say that v is get or init vertex v, and over here I say that over here that u is get or init vertex u, I cannot just say that v dot, and actually like what is this term? Yeah, this returns the vertex, right? So we say like a v dot out, this is the list, right? So we need to list push back basically v out u, right, is the idea. But is that actually going to work? I'm not sure. Let's try printing the graph here after I read this, right? So let's do graph dot print graph dot print g, right? That's all. So print is a function that takes graph g, and then we just print, right? So yeah, I need to say map. I need to do like map dot iterate g vertices. So we have a vertex. A vertex in a map is going to give me key and value, right? So key would be ID of the vertex. I mean, don't I just like give them these things, right? So like we have a reference to the pair, which is ID, and I mean key is ID, and value is the vertex itself. And then we just say here something like S is ID plus colon, right? ID is a string in this case. This doesn't work. Okay. So why does this not work? I feel like this doesn't work at this point because of the same thing, because this generic is on the outside, right? This over here cannot be awaited and stuff, cannot be inferred, yeah. Kind of makes sense, maybe. Oh wait, it's the data cannot be inferred, yeah. Can I say over here that const vertex data is you know, paths to target is integer, right? So this is a graph of vertex data is what we want. Okay, but it's still saying that this is not inferred and cannot be awaited. So yeah, the reason for that is the reason for that. Like, I'm pretty sure it's the same one. So I need to make all of these generic. Once again, vertex is generic type T. So there's going to be reference to vertex T. Wait, do I need to do that? Expected generic. What do you mean? T create T get right into vertex T vertex T. No, I don't think these parentheses are needed. Map T, value shape generic is not equal because this vertex is vertex T, right? That makes sense. Print is generic over T, T, map iterate, field iterate is not there. That makes sense now. Okay, and then error doesn't have fields. Graph, so it's not graph vertex data, it's just graph create, and now this can be like all inferred, I suppose. Expected type, so yeah, graph vertex, this is a generic, so it's something like this, right? And we can use that just inference here. So the only thing that is missing is the map iter then. So okay, let's do iter. Iter is basically the thing that takes the map, which is T. Why do I call this G here? Let's rename that to map. So this is T KV, I guess. This is also generic over K and V. And this also takes the function, which is taking the KV, I guess, right? And returns unit, like so. So we just do trip iterate, map inner using just a function. I mean, yeah, that's all. Although this over here is going to be a reference, I suppose, right? There we go. So now this compiles, it seems. It compiles, but it does not do anything. The graph print. Can I do over here? Oh yeah, because I'm not printing it, right? Over here I want to do print s. So this right now just prints. Wait, isn't s supposed to be a string? Yeah. Type shape main type main t. Wait, what? This is a wait, what? This is a string. Oh, because this is not this is print this print, right? So I need to do like stdio print then. Do that. Okay. So this just shows me all of the vertices, and as you can see, the vertices are all in alphabetical order now, because I'm storing a map, which is ordered map, right? So that makes sense. And then I want to print all of my outgoing edges. So I'm going to, so value is v as vertex, right? And then I'm just saying go like that v dot out, and this is a list which I need to iterate over the out, and so this is like u or whatever, right? And what? Well, I need to like store the vertex ID inside of the vertex, because I'm just storing the reference to the vertex directly here, which means that I need to have ID here directly inside of the vertex. So this is going to be ID then. So now that I have the vertex, I can get its ID, right? So u dot ID, and I say s plus equal this is the ID, right? U is a reference. Oh wait, this is a double reference. V out. Oh, because it's a because it's a list of references. So this is a reference to a reference. Makes sense. So we dereference one of that. S plus equal UID. I want to say something like, you know, like first is true, you know, and then over here if false, then no, not false, if first then print, not print, s plus equal space, else s plus equal comma or whatever. And over here I say like first is false. Well, I mean the space here. If first, then first is false, otherwise s plus equal comma, so that we can actually like print this properly. Okay, so is this proper? Yeah, so AAA has U and H. Okay, it seems like this is actually working. BBB has DDD and EEE, right? So I'm printing this in a different order, but that's but we have read the graph. And if I try to reading the graph of input txt, then it's actually reading pretty quickly. So like until it's reading the input is not the problem, it seems, right? Yeah. Okay, nice. Why did I think this would not work? Because over here I'm getting the reference to the vertex. So, and over here I am mutating the map, right? So like basically I'm storing a reference to the insides of the map, and then I'm mutating the map while holding the reference, which would be like resulting in compilation error in Rust. It only works because we're garbage collected, I guess. Here, and it might break in the future. Over here, holding a reference. Because the reference that I'm holding is to the inner. It's the reference to like the map key, right? And yeah, okay, I see. It's because my tuples like this. Even although like when I'm copying them, we are copying by reference, so the reference to the value is still the same. Yeah, I see. It works for maps, but not for generic trips, I guess. Maybe. All right. Anyway, so I have read the input, right? I've read the input. Now we just need to do the calculation, right? Now we just need to do the calculation. So let's see. Let answer be calculate. I don't know. Solve part 1. Right. dbg print. Solve part 1. Solve part 1. So I have a graph, right? And all we need to do is I need to solve. I need to solve for the vertex named something, right? So I will basically return solve for u, I guess, right? Our target is called out, by the way, right? Our starting vertex is u. And what do I need to do? So I need to basically do this. Graph dot yeah, hold on. I mean, sure, let's have a function get vertex, just get, right? So this is going to assume that it's already initialized. The graph tt id vid returns vertex t, right? I'm just going to implement this for now though, using get or init vertex g id and then function, then just the just panics and vertex not found or something like that, right? Okay, so now we have graph dot get. In the graph, I will try to find the name, right? This is my vertex. So vertex is just the vertex. Why is it the vertex of unit type though? It's not supposed to be the unit type. Oh, it's because this over here, get or init vertex. Yeah, this is supposed to return the vertex data, right? Can I like do over here? So this is supposed to be graph of vertex data, right? Which means that over here, paths to target are going to be initialized to -1. We could use option instead, but I have not. Maybe like we should, but I don't have that yet. So path to target is -1 means that it's not calculated yet, basically, right? Yeah. So we're just going to say here that if vertex dot data dot paths to target is equal to -1, then we need to calculate it. Otherwise, we actually are going to return this, you know, vertex result. Vertex result is this. I guess we can take a reference to that over here, ID reference, because over here we'll need to actually calculate it and then assign it, you know, is the thing. Well, I mean, if it's equal to -1, then we need to calculate it, and then in any case, we're just going to return the actual result, right? We actually will need to return the result here in any case. Okay, so how do we calculate it? We just go over all of the outgoing edges, right? So just do list iterate vertex dot outgoing edges, right? And then we have the vertex u. We have the vertex u here, and I'll say like actually solve can give me the vertex directly, and I'm just going to start at we're going to solve this for graph get u, you know, because there is no reason to like do that. We already have the reference stored there directly, you know. So that makes sense. Over here we have another reference. So I'm just going to solve for u, basically. This must be done recursively. So I must put this into a module, which is annoying currently because of the limitations, because of a bug. I need to, maybe like today I will actually fix this bug finally. But we need to basically solve this recursively, and then we need to what? We need to say over here that v result is equal to 0, and then we need to say v result plus equal solve u. So like the amount of paths from vertex v to the target is equal to the sum of the paths from all of the outgoing edges, right? So target is out, right? I'm just going to say that if vertex itself is equal vertex dot id, right? I guess if this is equal to the target, then we just return 1, right? With return then is what we're going to do. So we're doing like lazy dynamic programming here, so that we calculate each vertex only once, right? This just needs to be recursive now. This just needs to be recursive now, which means that we need to say const part1 module, and then we do solve like this. Well, I mean, actually, and this wait, hold on. Can I do a let here? I probably can, right? Which means that the graph still. Wait, I don't even have the graph here. This is just a vertex, right? It doesn't matter. So I just do part1.solve, right? That's it. So now this knows to be the vertex here, yeah, automatically. Let's see. So the answer is 5. Is that correct? 5. Okay, let's go for the input txt. The answer is 615. Is that correct? There might be overflow though, right? Potentially. But that's the right answer. Okay. Yeah. So this is pretty easy. I mean, I have just written a lot of stuff which should be in the standard library, of course, right? Like the map. And then... yeah. So this is part 1. That is done. Day 11, part 1. And what about part 2? Is it also easy? Thanks to the partial analysis, they also have figured out a little bit about the issue. They now know that the problematic data passes through point DAC. Okay. And FFT, a device with preprompt fast Fourier transform. They're still not sure which specific path is the problem, so they now need you to find every path from the server rack to out. However, the paths you find must also all visit both DAC and FFT in any order. Okay. Understandable. Understandable. Is the graph still acyclic though? Is the question. I mean, it is because the input is the same, right? So basically now our dynamic programming is going to include the two variables, whether we have visited DAC and whether I have visited FFT. In addition to the vertex itself at which we currently are. That's it. So it's going to be very similar. I call this DP. And I say over here, solve is DP graph get G and U. Can I do that? Then over here we just say dbg print part1.solve. It's supposed to be like the same thing, and this is like part 2 here. Right, the same stuff. Okay, so part 2 is just means that, well, I mean, part 2 means that I need to like store the different data, right? Because path to target is now not an integer, but the thing, like that, what do we calculate, right? Can I do this without copy pasting? Vertex data. I mean, I can just put both solutions here. For now, you know. Let's just say over here dot part 2 is going to be part 2 data for now. So for part 2 data, I need to store it's basically like a 2D array, but I don't want to use arrays here, so I'm just going to flatten this, you know, like you know, I just going to be like int 32, int 32, int 32, int 32. How about that? No, because I cannot do that by indexing. Let's do dot true true dot false false, I guess. Yeah, sure. False 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 true, true false, and true true. You know, instead of a 2D array. So like we have two things where I have visited DAC and whether I have visited FFT basically, right? Visited DAC, visited FFT. Right, so over here, then I say that dot part2 is all of these are going to be -1. Okay. I could not find false in the scope because it's not a colon anymore. An equal. Okay. Yeah, so for part 2, we're just okay, yeah. We're just going to say that if v is equal to the target is now not out, the target is SVR. And I guess we just inline this here. This VR. This can be like out here, inlined. Doesn't really matter. Then I'm going to say that solve. This right here is going to be called DP. Right? So if part 1, then we do that. Otherwise, we do the part 2 solving. Okay, so we are starting at server rec, so SVR, and we are starting at not only the vertex but also whether I have visited deck and whether I have visited FFT, right? So we start by saying that I have not visited any of those vertices, right? So if I am now at the server, then this path is only valid. If I have visited DAC and visited FFT, because we must visit them both. Only then we return 1, and otherwise I return 0, because this is not a valid path. Right? Okay. V is that list iterate V out DP get vertex. Why are you not inferred here? Part 2. Oh, because this should be solve. No, but that doesn't really help. So DP is reference. Wait, but why is DP a reference? Do I need to restart the language server? No, that makes no sense. DP is a function that takes 3 arguments now. So what's the problem? The 2 arguments are booleans, and this argument is not inferred for some reason. Why not? If I like remove this, it doesn't really matter though. Wait, now it is inferred because list iter v out. But this is the same type as before. Type shape underscore is not equal. Oh, it's because like it's because I'm calling this recursively, right? That's the problem that breaks the type inference. Yeah, and to like fix where the position the like thing is, where the error is reported or something. So result plus equal DP u visited DAC and visited FFT, right? What does it mean that DAC has been visited, and where does it mean that FFT has been visited? I'm just going to say that over here, that visited DAC is basically visited DAC or v dot id is equal to DAC, and similarly to that, end must be expression. Well, first of all, this is an or, but yeah. What's the problem? and visit FFT is this, or if I have visited FFT, right? What's the problem? And must be expression. Oh, it's because this is a place expression. I see. Have I not used the ends? So because this is an expression and this over here is a place expression. Yeah. Makes sense. I need to fix that in the language really quickly. I just need to go to the core syntax and must be expression right over here. If this is a place expression, then it should be compiler.temp expression module C AST right over here. And in the OR is the same thing. This is going to be say OR. So can I say let x be true and true? So now I can do that, and this was not possible previously, basically, right? Fix and or as place expression. Now we update the language, and I feel like this is all. So this is just going to be solved now. No, it's not going to be solved because this is not past the targets. Because now I need to like say over here, I need to match. I don't have a pattern matching against booleans, so I will have to do something like this. You know, if visited DAC, then one thing, otherwise another thing. You know, let's say data is v.data, right? Data dot part 2 is what I care about here. So we just do nested ifs. Visit FFT, then. So this is now true, right? This is going to be data true, right? This is going to be data true false, and this is going to be here data false true and false false. It says 5, but I mean we need to part 2. Vertex is not found. It's like a different example here. They give a different example. So you see over here example part 2 txt, right? So this is part 2 example part 2 txt, right? It says 0. Why does it say 0? Okay, it did not work. It did not work first try. Let me see. It's because it's wait, hold on. SVR, DAC, and FFT, right? And we go to wait. This is not SVR. This is what? What do we need to go to? We need to go to out still. Okay, so we need to go to out. We start at SVR and we go through these things. Okay, it says 2. There are only 2 paths. Okay, nice. So now we just do part 2, the actual input txt. And there you go. Now we need the int64s, right? Now we need int64s. int64s. Let's see here. This must be int64. -1. Because yeah, as in 64. I still don't have the casting. Right, I'm just going to add this to the top again, and I'm going to say that to like 0 is as in 64.0 and 1 is as in 64.1. That's how we do it here. So over here I return 1, I return 0, and result is 0. 0 here, right? And this is equal to -1. And now this is supposed to compile. And this is my answer. And this is the right answer. All right. That was easy. That was, I mean, it did take an hour, I guess, but I was parsing the input very slowly, I guess. Okay. Day 11 part 2 is done. So, okay, but it means that I have more time to actually improve the language now, right? Now we see all of these issues that need to be addressed. Let us implement them. So there's a couple in this day specifically. One of them is this is ugly, right? One of them is that this is ugly. And the other one is that I still need to do this as in 64, right? Yeah, and another one is that I cannot do a module inside of a function right now. So like instead of having this the module itself to be generic, I must every like thing inside of it to be generic. Okay. Mm-hmm. Mm-hmm. So over here, false, 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 true, true, false, true, true, right? This. So I could technically use a list, which is right now backed by a trip, and it would be fine. Having the actual arrays though would be nice. For that, right? Yeah. Having actual arrays would be nice here. So I think implementing arrays would be a good thing. But if we speak about arrays, then the idea that I had is that what I want, like I want something like this. I want to be able to say that type like foo is a type which has like integers. So this is basically the array of integers. You know, this is basically the array of integers. But we can also like prefix it with other types. You know, like this. So this is like similar to TypeScript, where I'm not sure what the syntax is exactly the TypeScript is using, but something like that. Which means that this is also part of the tuple. So we already have tuples which can have unnamed and named fields, and now we just can have the listed fields, I guess, or whatever. The reason I want this is because this is how we do like a lot of things, I guess, like functions that take variable amount of arguments, and stuff. Everything. There's no reason for this to be its own dedicated type. Kind of. Like variadic generics and stuff will allow to do a lot of things. We can make a dedicated array type, sure. But there's also, so like this over here is the like dynamically sized array, I guess, though. And we also need to do the fixed sized one. Yo, Infinite Coder, hello there. Did you beat the Nerd Souls game? I just solved the Advent of Code. It was really easy today. So I'm just going to work on the language now. Beating it. Came with the came with preparations with the clip.
It's going upbeat. Let's go! No! Go away! Go away! No! No! No!
Made in Rust, by the way. I wasn't trying to make fun of you saying no. I was trying to show that this game is made in Rust, you know?
No! Go away! Stop! I still say F. Oh, come on! Why is it still saying F? Okay, clip that.
Well, F. It still says F. You made the level a bit too difficult. All right. So I'm right now thinking about how exactly do I want to implement like arrays into my language. And what what I was saying is that maybe I want it to be part of the tuple. So right now we have already tuples with both named and unnamed fields. And what about variadic fields too? If you have an opinion on that. Indirectly because decided not to count, you have evidence, you have a WOD. Okay, so Nerdsoul's just game buggy. Fix your game, Nerdsoul. Yeah. Is there so let me see TypeScript fixed sized array. I'm wondering how they do this. How do you declare a fixed length array in TypeScript? Array number. Like this, like is there a better way than saying number? Did you say you're making arrays as variadic tuples? Yes. Because why not? Like, what's the difference? Like, what is the difference? Right? And like TypeScript already does it like that. But like I'm saying, this over here is basically the like we don't know the length of it, right? So this is a dynamically, so this is basically is going to store the length inside of the tuple, right? But then how do we do also a fixed sized one, which should also be there's fixed length array. Fixed length array. Array typed with fixed length. What about this? Rescript. I guess use a tuple for this. Help you, Gorley. TypeScript fixed type for fixed size arrays. Is that a different one? Fixed size array to string. And this is okay, and this is a type error. So they actually need a package for this? Is this not built into the language? Fixed size array extends. So n is a number, t is a type, n extends 0 question mark never. Otherwise this. And read-only array. Length n, 0 is t. We use numeric literal types for length, as TypeScript does 2.7 does for fixed size tuples. Numeric literal types. I mean, this is a numeric literal type, right? I guess. So if n is 0, basically, then it's a never. Otherwise, like, this is the only thing that we care about, right? But where's the other fields? Why is there only the field number 0 here? That makes no sense to me. Can I open my TypeScript thing somewhere? Like my online playground of the cast. Can I just say something like type array 2 t is 0 t let a array 2 in number, I guess, is 1. So this works. What if I say 1 and 2 here? It still works. What if I say 1 here? It doesn't matter. So, like, I guess in TypeScript, if you declare... Wait, what? No. Property 1 is missing in type number. But required. Okay, so property... Wait, what? Property 0. Property 0 works. Type T. Wait, what? So I guess I don't understand what this means. Because I expected that this means that there is only a single thing here. There's some magic going on, yeah. TypeScript numeric literal types. That's not how I want it to look, I think. I mean, so literal type just means that you can, like, the type of hello world here is not just a string, it's a hi world, I guess. Yeah, you can use the values as types, basically, right? Which means that this can only match this value and not any string. That makes sense, right? Numeric literal types is this. Okay. Map config, okay. This does not show me what if... This page has been deprecated. Okay. Can I say 0 colon? There is no 0 colon on this page, right? Everyday types, because not an everyday type. Reference. Type compatibility. Can I see 0 dot, 0 colon? Exactly one property named 0 of type T. Okay, but why can I assign a list to it? Oh, because JavaScript arrays are just objects with numeric keys, and TypeScript shrugs and does. Okay, array does have a 0 property, close enough. What? Because 10 is literally 0 is 10. Okay, but why does it work with arrays? Oh, I see. I understand it. We don't type check, though, is what this means. What this means is that we don't type check the elements at other indices than index 0. No? So this npm package that I looked at is not correct, right? If I say 0 is t, and I say this is array numbers, then and I do over here string, this still type checks, but that is not correct. Because if I say 1 is t, right, then this is going to not type check anymore. So this package is incorrect. Okay. Yeah. I mean, I guess no one uses it anyway, right? I mean, there is 700 weekly downloads. Is there total downloads here? Yeah. Wait, so there is a warning. Classic tokens have been revoked. That's something else. Okay. So is there, so like the only way to type, like I need to, yeah, like for a fixed size array, I need to like actually list everything manually here. There is no syntax for it in TypeScript, right? TypeScript. Fixed sized array. Geeks for geeks. Like, that's how you do it, right? Fixed sized array, type 1, type 2, type n. And you cannot do that. How do you specify a fixed size array type where each element has same type? Use a tuple type, yes. So I actually have to repeat. Okay, but we can come up with a better syntax ourselves, right? For this, if you use Rust, we can do this. There's also a thing that is called tuple, like unpacking. You know, that's the other thing that we don't have right now. Let's say that I have a value like x, which is, you know, x is 1 and y is 2, right? And I want to say that x, so like x is dot x, but we update x to be equal to 2, right? Something like this, where we use the other fields from the existing data, right? X, Y, Z, right? So this is just supposed to update the field X, and the other fields are the same, right? So let's say that these are actually unnamed fields, right? So we just say 1, 2, 3. And over here, I want to append this to that one, right? That would be like just the 0 and X, right? So this is supposed to be like 0, 1, 2, 3 then, I think. So it doesn't do the this thing, you know? So what I can do is what I mean is we can create like a function that does that thing for us, right? For example, we could have a function, you know, fixed size which is going to take like the number here, which is int, and this will return the type where, you know, field number is 0. It's basically like yeah, the amount of fields. I guess we can actually like describe this by something like that, you know. If n is equal to 0, then it's going to be the empty type. Otherwise it is going to be type you know, dot n minus 1, or I guess, yeah, it's going to be like dot 0 is of type. So it's like n and t, which is a type, right? So 0 is of type t, dot dot dot, or like whatever syntax we use, probably 3 dots, dot dot dot, fixed size n minus 1 t, you know? Does that make sense? So in order to construct a fixed sized array of size n, we just do it recursively like this, right? We just do it recursively like this. So I think like fixed size arrays is like a separate feature. So fixed size array only needs the unpacking then. And for this I can use like existing tuples, and for dynamically sized it's a little bit different. Fixed size is like known at compile time size. Yeah. And then but what's the difference between this? So in this case the dot 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 is unpacking, but in the case of the of like dynamic, like dynamic list type is like dot 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 int32. It's not dot 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 int32 basically, like it should be like, you know, it's something like dot 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 is of type int32, right? So everything that we like all the rest of the items must be of type int32. Is that a good syntax? Because I don't try to unpack the int32 into the rest, right? Because yeah, so we need some different for the syntax here. So so this requires 2 new syntaxes. One of them is like having a field which is like indexed, which is what I was planning to do anyway, and then the unpacking, which I was planning to do anyway. Like we need this anyway. This one is something that we can like think about whether this is needed or not. Dot nt and fixed size n minus 1 and t. It's the same. It depends like how unpacking works. I feel like like when you do unpacking for named fields, then it only unpacks those names that are not present before, which is like how it works for like updating the struct syntax, right? But for unnamed fields which are indexed, it should just append the unnamed fields. So the one that was index 0 here is going to become index 1. You know? Because how do you, like, for example, combine two tuples, you know? So like when you say like combine, combine is two things. I don't know. Let's say that you have like A is a type of integer and in 64, right? And type B is I don't know, like string and boolean, right? Then I want to have like a type which is A and B, like this. So we unpack multiple times, and this will be basically equal to int32 in 64 string and bool, right? But if we have a named field, then like we have a x. I feel like for named fields, if we do unpacking multiple times, though, it should not work. Like the same syntax is going to be also used for passing the arguments into the functions. You don't know much about Nim, but all this compile time wizardry feels very Nim-like. I feel like you should be able to do the same thing in Zig. It's just you don't have the syntax, but you can have this as a compile time function, basically. In Zig, I think. So in Zig, you will just have a function. Like instead of saying ... you will say like extend unpacking. You know, like origin, like, you know, something like A and like thing to unpack. Right? You know even less about Zig than Nim? Well, I know a little more about Zig than about Nim, I guess. But yeah. So this will allow me to have fixed sized arrays with the sizes known at compile time. You know? And this is known at runtime. Those are two separate features, I suppose. And we can start this with this feature, where we just like so, and then how do we access the how do we index into the array, right? We don't use the indexing operator actually, because because they are similar to fields, right? We just say .0, .1. If I want to index it with a variable, we can say .I. In this case, we do parentheses, I guess. Right? I know that there are other languages that do this syntax. I think OCaml is actually one of these languages that do this. Right? Camel array indexing. I use the functions get, but you actually can do even numbers .2. Right? Is there other languages that do the same syntax? Later, we can also upgrade this to support actually like first class labels and stuff, you know? So if we have a named field, like we can say something like name is field, and we can like access the name here of a tuple, you know, tuple.name like this. So it doesn't have to be an index, right? It should work with like both types of fields. Maybe this is some like, I don't know if we can make this same stuff work for like maps, for like custom ones. You agree that these kind of syntax decisions are not a big deal though, right? Well, I mean, I need to like implement something, right? So I need to choose something. I can always change it though, yes. It's just like right now my square brackets, they don't mean indexing, they mean instantiation of a generic. I can make the square index to work as indexing at the same time. That will require a trait then, which is indexing, I guess, which would be automatically automatically like implemented for generics, I guess. Then we could use the square brackets, which is more thing, which is something that is more like familiar, I guess, for most people. What about Rusty CPP? Angular brackets? Yeah, I don't like angular brackets, no. I mean, technically, instantiating is indexing. It's not different. It is actually not different. Because a generic is a family of, like, types. For example, if you have a generic type, it's a family of types, and you index into the family by, and that gets you the concrete type. There is nothing different. Like, instantiation is indexing. But right now it's implemented separately, so I cannot easily reuse the same syntax, I guess. It's just I mean, yeah. It is literally just indexing, and it should be implemented through a trait for generics, I guess, later. Let me just go with my current plan first, though. But I'm just like, and like, I guess also we could, similar to TypeScript, instead of saying .0 is of type T, we could use the same syntax as TypeScript, which is like element indexed by 0 is of type T, right? Can you do that in TypeScript? Is it literally like, I mean, in TypeScript just say 0, like this, right? If you do that, I think this means the same thing, though, right? Yeah, it means the same thing. It's just it is different syntax, even in TypeScript. Well, I mean, in TypeScript you don't do dot here, right? But like, yeah, you have two syntaxes saying the same thing. So maybe we will support both. Let me just start with something. Okay, so first thing that I want to do is to have T is instantiating, whereas I is indexing, accessing. T is instantiating, creating a new index, where I is indexing, accessing an existing index. That's even that is not really true. I mean, it depends on like the language, I guess, but indexing can create a new thing. Is the idea. If you use a language like C++, for example, then you have a map, and if you index into it and the key doesn't exist, then it creates the new thing, basically. Yeah, right? That's the behavior in C++. I'm pretty sure that it can be the behavior in other languages too. And like, even in Rust, we want to have even in Rust, there is there was the RFC, which is called index move, literally, right? Because it is because this is a thing which you want to be able to do sometimes. Sometimes indexing, for example, indexing into a matrix, right? Indexing into a matrix, or I don't know. You can index into a matrix with like with a tuple of two ranges, for example, to get a submatrix, right? In order to do that, you would be able, like, you cannot just return a reference, right? So, but right now in Rust, all of the indexing operators, there's index and index mut. One of them returns the reference, another one is returning the mutable reference, right? But in some cases, you actually want the indexing to return like a new object, right? which is kind of like similar to creating a new instance when instantiating, right? Not exactly the same, but you know, people want that, you know. So yeah. Let's start by implementing tuple dot 0 syntax. Let's start with accessing the field number index, right? Because I can not do that right now anyway, right? Yeah, so what I want, if I open cast here and then I say like let x be 1 and 2 and then I say x dot 0, this doesn't work because field might be identifier, but it is a non-number right now. T is type stuff, I is value stuff. Yeah, but for me types are values, so there is literally no difference. It is a difference in like these languages though, right? But for example, Python also treats types as values. So in Python, you also instantiate generics with the indexing operators, right? Knew you would say that. Yeah, but also like Golang also uses these square brackets, right? And Golang in Golang types are not values, so but they still use the same syntax. So yeah. Anyway, as you have said yourself, the syntax decisions are not a big deal, right? Right? Yeah. I'll just do something. I want this to workspace too. Okay. Field must be no, hold on. Field must be identifier. Yeah, so there we go. So we have the expression of the dot. This is a place expression. Object dot field, right? And in this case, the field is not the identifier. In GDScript, class is also an object, Lua2. Yeah. JS2. So we need to like do a more generic like here's my place expression field, right? Where when I'm creating the field, my field is always a string, right? But I feel like the field should actually be what? It should actually be an expression. Not always an expression. Field. Like what do I call this? Like field expression. You know, where field expression is either you know, index of int or a named string, or it could be like any expression, I guess. Or it could be any expression. In this case, we just store expression inside of the index, right? Do I call it field expression? Like, what do I call this? Also in tuples, I call these members, not fields, but I mean, it's kind of like the same. Sure, field expression. Okay, and now I just actually, you know what? I'm just going to open VS Code. Okay, so now I just need to go here. So we have a place expression field, but this is printing it. Okay. Do I do print maybe escaped? Yeah, instead over here I say print field expression options field. And print field expression options fmt field. Fmt is function index I mean string s. Then we do string print maybe escaped fmt s. So function fmt okay, fine, I don't do function to match field with, right? So this is going to be field of type field expression, right? There we go. Not string, it's called named. It's called name, right? So we have name, we have index I, then we just do printf mt %di, and then we have expression e, then we just say printf fmt. So I'm going to put this expression in parentheses, right? Like this. Right? Which is going to be print expression e options print field expression print field. There shouldn't be no expression. Oh, print field expression. Yeah. All right, next interpreter. So now in the interpreter, my field is a field expression and I need to do a match on it, right? So we're going to match okay, we're going to say that that member is going to be match field with index I, then index I. This is going to be tuple member, right? Okay, and then we have name, then name, right? We have expression e, then we need to match evaluate e. So it's going to be value int 32, then we get index index I, we have a value string, and we have a name s, and we have anything else, then we return. Is there a return here? There is no return. Member. Can I say like sum? And this is going to be none? No, I don't like that. I don't like that. Index 0. So over here, get, Okay, I guess I want a get opt field member here. So I need to implement the get opt. This is field span, or I guess a data span. Field label must label incorrect type. Let's just do that. Index 0 is not what I want though in this case. In this case, I should just return the error. In general. I guess sure. In this case, I do the option here, so I'm doing some, none. So then I'm going to match member with some member. Then I do that. What's the problem with the syntax again? Parentheses. Okay, so over here, if it's none, then I just return error place. Do you prefer symbols or keywords or exactly 50-50 of both? It depends. It depends. For some things, I prefer keywords. For something, I prefer symbols. For example, for math operations, I prefer symbols. For plus, I don't want to print add, but I have just the symbol plus that I can print, right? And for getting a field, I want a dot and not to say get field, right? It depends. There's no preference. Dot add hater. Yeah. Have you never written the code which has like dot add and dot mol dot sub? You do that even in Rust if you want checked stuff or whatever. Well, I mean, there are new types though, but I'm not using those. Yeah, maybe could do that instead. In Rust. All right, I want to have a get opt member tuple is just going to be get unnamed opt and get named opt and get unnamed opt. Is what's checking get opt. There we go. What about a field 0? Yes, that's what I was talking about. Why would you want that? Are you making that yourself for your language? Tuple get opt, a member tuple. That's what I want. Field does not exist. Member field. Can I do tuple? Member print. I'm actually thinking about asking Dev 9-inch nails, yeah, if you would like to write the interparser for your language. Is Dev Ninja specializing in parsers? I guess member here should be evaluated immediately. Which means that I don't want this to be an option. Let's do over here. There's more theory and better opinions. You write Lisps. There's nothing wrong with a Lisp. Why don't you just make your language a Lisp? If figuring things out that are not Lisp is difficult, you can just skip the decisions and just do a Lisp. Then there is no decisions to be made, right, about syntax. It makes it a lot easier. Nobody wants to write Lisps. Well, that's not true. There's a lot of people who like it. It's just there's a lot more than don't. I guess. But out of the people who don't like Lisp, how many people actually tried writing a Lisp? Because, I mean, have I written a Lisp? No. So maybe I just didn't try it, and I would like it. Who knows? But I don't want to try, is the thing. You should make a Lisp. You do not like Lisp? Or Lisps are, most Lisps are dynamically typed and are targeting statically typed fan bros. There are Lisps that are statically typed though. It's just, yes, there's not a lot of them. Because Lisps are languages that specialize in like ultra simplicity, right? And type systems is already complicating the language. Making a dynamically typed language is, of course, a lot easier. A lot simpler. I want to like return here. Can I return, please? Can I return? Can I please return? Can I please return? Let's do over here with return. Return. It's a function here. Over here, I'll just return error place expression data type. Okay. So member is actually this, right? So there's no reason for me to be matching on it anymore. Okay. And over here, we're matching not the field, we're matching member. And it should be name. In this case, we do that. In this case, field doesn't exist in the target. Tuple member print member. Okay, next. This is the compiler, initialization. So when I have initialize place expression, we have place expression field, which has a field, which is a field expression. Tuple get named opt. field. Okay, so in this case, what do we do in this case? What do we do in this case? I can just say that the expression ones are not supported yet, but like, how do we infer the type of the dynamically calculated field, right? How does it work in like dynamically calculated should only work if, like, for example, all unnamed fields or all named fields are of the same type. Only then it should work, right? Yeah, makes sense. But let's say for now that it's not supported. So member is going to be, why do you want tuple.0? Because what is the other, like, I cannot get, like, the only way to get the element number 0 from a tuple right now is to pattern match. That's how we do it in OCaml here, and it's very annoying. So like if you have a tuple, something like value like tuple is you know, like 1 and 2, you need to do FST. But what if it's a tuple with 3 elements? Then you cannot do FST anymore. It just yeah, it doesn't work anymore. You cannot do FST tuple here because FST only works with tuples of size 2. I don't like this. This is bad. We want more generic mechanism. Third tuple, yeah. Indexers. I mean, yes, indexers. Can you do indexers in for tuples in OCaml here? Tuple.0. Does that actually work? No, this is the indexer. This only works for arrays, literally. Yes. So like I want to like make this like that, like basically I'm going to implement arrays with tuples is the idea. Tuple 0. Yeah. That also doesn't work, you know, OCaml. In OCaml there is syntax for indexing, which is this, but it only works for arrays, as you can see here. So yeah, I think I want this to be supported. Probably like the actual like indexing the square brackets also should be supported. We were talking about this earlier. What's the syntax going to be for dynamic arrays? The same one? The same one as for fixed size arrays. Like, I don't want it to be different syntax. It doesn't make sense to me to make things different. So in my language, you make tuples like colon 2, colon int, colon stir, and colon 3, colon int, colon char, colon stir. Why is there so many colons? It's a Lisp, but in addition to a lot of brackets, you also have a lot of colons. Okay, but yeah, for now I think I'm just going to say that member. This is going to be tuple member. It's going to be match field width. Field width. With index I. Name as and expression E. So in case of expression E, we're just going to save for now. We're just going to save for now error span to do expression field access, I guess, and I'm going to return, which means that over here I want to return. Can I do over here with return? Are we gonna get back to the Rust problem of indexing and panicking? Yeah. Yes, it's going to be handled through the effect system instead, right? Naming convention for types. What do you say, naming convention for types? The colon int. You have naming convention that types start with a colon. What about the 3? 3 is 3 also a type? In your example? I mean, you don't want different syntax for when it can panic versus not. Yeah. No. Hey, actually not. No, I don't want different syntax. I actually don't want different syntax. We were talking about that too, right? I don't want different syntax. Why would I? When you add numbers together, do you want different syntax for when the like the addition of a tuple, like of integers, should be checked or unchecked or wrapping? No. Tuples in JS are fine, just regular arrays. Yeah, that's basically how we're going to do it here. I'm kind of mimicking JavaScript, or like TypeScript rather. Right? It's just when we're going to compile this, it's going to like be backed with fixed size data structures. I guess it's in general like what I'm doing in this language is more similar to Lua. Hello, Sishumara. It's more similar to tuple, where we have like the single thing, which can be an array, a map, and like everything, you know, kind of. So I have this type which is called tuple, right? But tuples normally in your programming languages, they mean that it is a fixed size thing where every field is unnamed, unlabeled, and the types can be different, right? But we already can do both unnamed and named fields. I'm going to add like the list support for that too, which is going to be very similar to the way TypeScript does it, basically. Lua, your array starts at 1 and not 0. That's actually another thing that I was thinking about. I feel like it should be customizable. I am planning to be using the starting at 0, right? But like sometimes you want to start, like, I don't know. Like sometimes maybe for some reason you want to start a different index. It kind of like maybe makes sense sometimes. Why do we need tuples with rank more than 3? Just pack tuples into other tuples. I mean, technically, yes. Technically, what is the difference, right? Well, the difference is the syntax. We don't want it to be annoying, but I mean, technically, yes, you're correct. It is. Wait, I mean, yeah. We can we just do the comma as a like the binary operator, right? And that's it. And it is. Yeah, I mean, actually you don't. You actually don't. That's correct. I guess. It's getting slower and slower for me to solve the puzzles in set. Today I only did day 5 part 1. Well, we solved day 11 today, but day 11 is like a lot easier than days 10 and 9 both, I guess. But you did not get to day 8 even, right? So yeah. But also maybe it's because I fixed the performance issues in my language. Users are never happy. Just drop that idea for users' happiness. Well, I mean, but I mean, you can have tuple like what I'm saying is that you don't need the tuples of length more than 2, because you can just say that like A, B, and C. This is just a binary operator, which is automatically parsed as this, basically. You know. So like from the user perspective, you are not even going to see the difference, right? You are not even going to see the difference. You can even implement the in the language when I have like, if this is a tuple, right? And then I say tuple dot 2, because this is statically known and this is more than 1, it basically automatically gets translated to tuple dot dot 1 dot 1, I guess. Yeah, I mean, technically you can go and make your entire language with just tuples of type 2. It does simplify some things, I guess. Especially, well, like with dependent types, if you have a dependent pair. But if you, with dependent types, you want the tuples with bigger arity, then basically every next value can depend on any of the previous values and stuff, you know. But if you just have a dependent pair, then you can just like compose them easily, right? But the thing is, if you are doing it like without optimizing, then you'd say FST tuple. So FST is the function that now has an overhead. If you do it like the naive way, right? So maybe at least for that reason, we needed to have tuples of bigger arities. In C, would you rather write int A10 or int A0, A1, A8, A9? Well, you are asking that. But that's literally how you do it in TypeScript. I was asking ChatGPT earlier, and that, I mean, sure it's correct. There is no way. Like, if in TypeScript you want to specify a type of a fixed sized array, then you have to repeat it. Does OCaml have inlining? I mean, yeah, I guess, yes. I'm not sure if it does it in this case. I mean, what OCaml doesn't have, though, is automatic... Like, OCaml is a boxed language, right? So when you, in OCaml, when you have the tuple like A, B, right? Type tuple is A and B. Well, I mean, I guess, yeah. You know, like int32 times int32 times int32, right? That's how you declare a tuple type. So in this case, this type, since it's like the second element of this tuple, because of the way OCaml does its values, this is going to live in a different place, right? Because it's not, because every value is boxed, which means that there is going to be pointer chasing here. Even if you inline the function, you still are going to be pointer chasing with tuples of big arities. I'm pretty sure OCaml doesn't optimize your like type layouts, where it automatically unboxing things and like stuff. Pretty sure it doesn't do that. I don't know if in F. I think in F#. It probably is the same because it looks like OCaml, but I don't know because it's based on .NET, so maybe it's different in F#. Can you talk about day 1 part 2? Hello? What was wrong with day 1? Day 1 is the first one, right? What's are you struggling to solve it? My bot doesn't work. Did you solve the day part 2 with a solver or with code? You don't want to reach to a solver? I mean, no, I use my own language. My language does not have a solver, so I needed to write a solver myself, yes. part 2 is not working for you for day 1. I don't even remember what was this about. Following the same rotations. PowerPoint. I mean, if you want a tutorial how to solve this, there's probably like actually like tutorials online which can do it better than I do. You know, just look it up. How many time rotations, powers 0? Yeah, I don't know. I'm not very good at explaining this, I think, for the... I don't know. And it has been like 10 days ago, so like I don't remember. Do you think it's possible to brute force with pruning? In day 10 part 2? I mean, brute force like without Gaussian elimination, is that what you mean? Without Gaussian elimination? Probably not. With Gaussian elimination, the thing that we do in the end is still brute forcing. But there is like the better algorithm that can do it without the brute forcing after, which is called the simplex. But I did not do that. Return. Type new not inferred. Span field span. Are we planning on doing dynamic arrays? Why does this language have triangles? It's a pipe. Because it's just the alternative. In this case, it's instead of doing parentheses here, we can do this. Which means that I write the symbol in one place instead of in 2 places, you know? Just simplifies things a little bit. Sometimes syntactically makes it easier to read if you understand what a triangle means. But yeah, it's a ligature, so it's technically 2 symbols. It's just shown in my editor as a triangle. It's just regular school level system of linear equation, not high math. Yeah, I think Gaussian elimination is school. It's, yeah, it's pretty basic. But I mean, a lot of people forget about that, I guess, because they never need to do that. What am I doing here? We have expression here. Yeah, just save to do here. We have a member, and once inferred over here, I just say get opt member. Okay, and over here, field this is not there. Tuple member print member. Match member with name field a tuple member print member. I was bullied in school, so I missed out on a lot of math. I'm just behind. Never did linear systems, for instance. Yeah. I was just like, I'm doing game development, for example, as a hobby, and I've been doing it for a long time, and like because of that, I feel like the linear algebra is basically the most like the thing that I'm most familiar with from math. At least like basic linear algebra, matrices and stuff. All right, field is a string. Okay, it's not a field must be it's not must not. So this is the syntax, right? So now in the syntax, I'm going to say field. If this is the identifier, then it's going to be so this is going to be what? It's going to be what? It's going to be types dot field expression, right? So in this case, it's going to be name identifier name. And then if we have a simple token, which is a number, what is the type here? We have just a raw string, okay. What is the runtime for part 2? For me, it was really slow, but can you explain why operator in is needed over here? Is this not needed in F#? It's because that's the syntax. I don't like it. I hate it myself. Like, I'm not doing this in my language. In my language, we just do let and semicolon. But in OCaml, it's a let in. Basically. Just the syntax in OCaml done like that. But basically, my language has a very slow interpreter right now, so the part 2 was really slow. It was running for like 20 minutes, I think, after I did the like performance improvements of the language itself. But when I transpiled it for JavaScript, so the JavaScript version of my solution was running in less than half a second. It seemed really instant, so I don't know, really fast. So, yeah, and JavaScript is not the fastest language, right? So, yeah. I mean, like, complexity-wise, the algorithm is just, like, really fast, I guess. It should be, like, 50 milliseconds in C++, maybe at most, I don't know. It's not required in F#, yeah. That's another reason to like F# more, F#let. Let me just see. You say let, and final pattern is this, body expression. Oh wait, you don't even do the semicolons here. Is F# a white space sensitive language? I guess that's something that I don't like. So you don't even do semicolon here, right? You just is white sensitive. Impressive by cheating, given my situation. Well, I mean, yeah, it was running for 20 minutes in my interpreter, but yeah. Around 20 minutes. I don't know. I didn't like count. Yeah, I'm not sure if I like the white space incentiveness, but yeah. So if this is a number, then I need to say match number int of int. How do you parse a string in OCaml? I forget. There's toString. There's offstring. No, there's a float. Parse string int. What's it called? I forget. I need to parse. I need to look at my natives, I guess. Parse. Let's see. Int 32 offstring opt. Wait, what? Why is there no such thing in an int though? Or is it like the language server is wrong? Offstring. No, it is offstring. I'm pretty sure because it is offstring for int 32, for example. But this is an int. Unbound value of string. Like, as you see, there's int32 of string, but there is no int of string. Okay, it actually does not exist there. Oh, wait, no, wait. There's toString format, all float, to float, min, max, equal, compare, shift. Okay, it is string, what? String 2. String dot 2. There is string 2 bytes, there is string 2 sec. Wait, what? Why is it different? How to parse int in OCaml. Int of string. Like, why is this not inside of the int module? Why is it outside a standalone function? Int of string. Like, why? Why? Can you explain this? My problem, like, I mean, it's okay that it's outside, right? But why the different modules have different like things there? It's not like it's like not consistent, basically. Wrong. And int of string is raising a failure. Is there int of string opt? There is. There you go. That's what I want. So this should be failed to parse as a member, whatever. All right, and then if it is a complex one, then I want to say that it's a complex. I want to say expression. C compile expression field ast. Right? That's what I want. Field. So now we have a find binding field. Because I'm trying to find something in the compiler scope. The field in this case must be something else. Field is going to be a match member with if it's index int to string. Well, like there's int to string, for example, here int to, but yeah, to string is in the module. Of string is outside. Name as expression e, and this is going to be actually I need to have in the cast interpreter eval place expression. I want to extract this member, right? To the function that's called eval field expression. There's going to be state types field expression into tuple member option, I guess. And Can I say result? There is a result, right? Let's say result here. Tuple member or unit. Just to make it more clear that it's a failure in this case. Function state field into where is it? It's this one. Go to match. So this is, and this over here is going to be error unit. This one's going to be okay. 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 Like that. Match field. Field is A. Unbound times constructor field expression. It's not types. Not tuple. Okay, so over here we say that let member be match eval field expression field with okay member then member, and if it's error then we just return error place expression data type state error. Okay, back to the compiler for syntax. So yeah, this over here I'm just going to say cast interpreter dot eval field expression C state interpreter field this is a result, so I'm going to, I guess, match this with okay member, then I'm doing all of that. If it's error then we just return error. So if it is a member I need to have the field, so then field is going to be match member with index I, and then I say int to string I name as s. Okay, there you go. There you go. What is missing now? Where's my error? Over here, field. A label is create reference field ASP span field. Label. So now the labels of the fields, this is how return works. It throws an exception and catches it. We do control flow using exceptions. I'm not sure how much is it used in OCaml ecosystem in general, but I have seen other people do that. That's not something that I came up with. So you can like return from the outer function, from the inner function. I am planning to do the same in my language, but the huge difference between OCaml and my language is going to be that it's going to be checked by the type system, because we're not going to have just exceptions, we're going to have checked exceptions and like effect system in general. So it should not be able to, you should only be able to return from within a context which allows returning, basically. But it's basically like, it's not exactly exceptions. I'm just calling like I'm just having a more generic thing which is called unwinding, right? It's not, I'm not calling that exceptions, I guess, in that case. Nothing exceptional about returning a value from a function, right? But we do need to unwind the stack in that case. Is there no such thing? Do people not do that in F sharp? F sharp return? You actually do the monadic binding here, and you use this like syntax, right? So this is the do notation. Yeah, the do notation I guess is easier in F sharp. You can do something similar in OCaml, but it's annoying, in my opinion. And just doing the exception is fine. Return using exceptions. Is that something that they don't do? That you don't do? Why does F sharp have exceptions? Why? Is implementing early return from function in OCaml idiomatic? No, it's not idiomatic. But I've seen people do it. But I've seen respectable people do it. Respectable people also wear sandals with socks. Yeah. Camel with return. Like I literally copied this from somewhere. It's base. It's like literally Jane Street, which is the company that is most famous for using OCaml, right? That's what they do. They just say return, and I like literally just copied this from here or somewhere. It's part of the OCaml core library, which is basically the standard library. Instead of like the OCaml standard library, there's a Jane Street standard library, which a lot of people use, I guess. And that's just implemented using exceptions. It doesn't say that it implements. No. Or does it? It is only because of deficiency of ML types that with return doesn't have a type. And there's also like some deficiency of the ML types, that they are not this type. Oh, because this is higher kinded polymorphism, I guess. Because the function, this cannot be a polymorphic function. Yeah. They don't say here that it's implemented with exceptions, though. It says that if your function raises an exception, then it escapes with return, but can I see the source code here? Jane Street core. Core. With return. Base with return. There's a file called with return somewhere. Am I right? With return is with return. Module with return is with return. With return. TUVW. Wait, where is it? Where is this coming from? With return. Is it imported? Module with return. There's no way. Oh, it's base with return? Wait, what is base? What's base? Base is not core. There's core and then there's base. What's base? Base is not the standard library of OCaml, right? Where's it coming from? Where's the Dune file? Libraries base. Okay, there is a base. And so I need to find Jane Street base, right? This? That's a separate repository, okay. And then here we have with return. There you go, there you go, there you go. Look at this. With return, we just have exception here. And then when we return, we just erase. We erase without a backtrace so that it doesn't have the overhead, performance overhead, I guess. Although, I mean, I implemented in a different way, maybe because of that. Maybe I can like improve the performance of my compiler right now, of my interpreter right now, by erasing without backtraces, because I'm capturing backtraces right now every time, because I'm not using this, right? With return option. F return is function A, return sum A. So function returns unit by default, but I can only return a value. Okay, I see. What is prepend? Yeah, and then there's also something else, is alive. Why do they do is alive? If not is alive, then use of return from with return that is already returned. Okay, just like a check. Okay, and I don't do this check either. Yeah, so like technically, like the type system doesn't prevent you from misusing this, right? From saving this and like calling it after you actually already returned from the function. This is auto wrap value into option, but you can basically only return from a function the sum if you use the return. Basically, and but the function itself has returns unit here, it seems. Belongs in common, but moved here to avoid circular dependencies. Of course, was some issue in OCaml because of which they did something. Okay. So it is not where it belongs. Nice. Let me just copy this. I'm just going to see if this changes the performance. Can I do something? Can I do like... I mean, I need to finish this first, though. What I was actually doing. Before I was, for some reason, looking into the returns. But yeah, it is a little weird, right? But like generally, it is considered that using exceptions for control flow is bad, but that's literally what people do here in Jane Street, right? Because it's the most practical thing of writing OCaml, I feel like. You reach out to these hacks because of the language, I feel like. It gives you this tool, and like this wrong way is easier than the correct way, basically. That's what I would say, I guess, about OCaml. It's interesting to observe how your random words in chat, my random words in chat, materialize into ideas. Your words materialize into ideas. Wait, what idea just materialized? The only idea is like to check the performance, I guess, because I didn't actually look at the implementation when I did my own with return, right? I didn't look at their implementation, so I'm just doing the exception raising. I guess that's the idea that materialized. So it's good that I looked there. Okay. Let me see here. So this is what? This is me trying to compile the expression field. And this has the label so that we can rename things. So now labels are like optional, I guess, right? Labels are optional, I think, in the place expression field. They are optional because it's not necessarily known statically here. But I mean, also, it means that the label doesn't even belong here. The label belongs into field expression here, because if it's name, then it should be string and label t. I mean, maybe it should be just label t here. What is a label t even, right? Because I can get the name of it. Like so, yeah. We are going to go through interaction though if we do that. So do I just do as a... I don't want to do optimization here. It's easier to do it this way. Place expression. Place expression. Like that. So we move the label from here into here. So in this case, as this is going to be a label get name of s. I guess I can like put this into the label itself so it stores the name directly instead of like that. I can access it faster. If that's even needed. I'm not sure if that's needed. Evaluate field expression. So over here we say name. Yeah, over here we have a label, right? So this is going to be a label get name. There is no label here. And then the compiler, we do not have a label. This is going to be label. It's going to be label get name. Label. Label unite label. So label unite label. Label now only exists and now I need to only do this if we have a label, right? Type field label. Yeah. So this should be returning. Should not even be like tuple member then, right? Because I need to save the label itself. This is important for the LSP here. For renaming. So label and member in this case is going to be like none and index. In this case, going to be some label and this. Right. Tuple member label option times that. Unit parentheses. Match label with some label. Then we do the unite. And we ignore that. And then I don't do anything. Is there an if let in F sharp? F sharp if let. If let expression, F sharp length suggestions. I see a suggestion here. Close as not planned. Why is it not planned? It's an instance idea, but in the closest syntax, I think this becomes a let some idea in this. So you just have let in. Wait, so in F sharp you still have a let in, which is basically an if let, right? Or like, because this is, because opts ID can be potentially a none. So what's the, is this going to panic? Apart from this raising a warning. Why is this raising a warning? Because this is not exhaustive pattern matching, right? So the main purpose of this suggestion is to get rid of the underscore unit part of the match expression. Literally never felt the need for this feature. Probably not. If flow typing system were added to F sharp, it may be different, but for now, an explicit use of match is the way to approach this kind of elimination. Sad to see this discarded. What do you think? You use F sharp? Have you seen this suggestion? If let is if let but better. If let but better is an open discussion now. Well, basically an if match. If opts ID match some ID, then this. Just a different syntax for an if let. And I guess that's how I plan to do it, but instead of a match, it's going to be the is keyword. What languages do you code in? Right now I'm coding in OCaml. I also code in Rust. I'm making my game, as you can see on the top right corner. That's written in Rust. For a job, I do Java mostly. Some other languages. But I have tried other languages too, briefly. I mean, some of them, not really briefly, but those are my main languages, I guess. C#. Have you tried React? No. React is one of the things that I never tried because I'm not a front-end developer. Rust and OCaml, the antidotes to Java job. Yeah. I feel like if I looked at React, it would be really easy, but I just never, I don't know. I did write a little bit of like TypeScript every now and then, but I do it without React. Like my playground for my language is just written with like plain, I guess, HTML and TypeScript. For the website itself, we use static website generator, which doesn't have any JavaScript in it, basically. Are you able to slip Kotlin into the work code space? We actually tried that, yes, but I didn't like it. I didn't like it to be used as a, like, try to inject Kotlin into existing Java code base. I found that not very nice. So like, I don't remember why. I was trying to do that like a long time ago, maybe like 5-8 years ago or something. I feel like if you write a code base from scratch, then doing Kotlin makes more sense. But if you have an existing Java code base, just stay in Java. I'm a TechOps engineer and trying to understand Kubernetes, Docker, and some TypeScript. For me, I'm like struggling to understand it. I've never coded in my life. The only thing I've done is PowerShell scripts. Big W, yeah. Well, you just need to learn programming, I guess, in general. It doesn't matter what language you use. If you want to do programming, although Kubernetes and Docker is not really like programming, it's just understanding the tool. TypeScript is a programming language, right? And Docker is not. The field access ident name has type string. Okay, let me like on here. What do you recommend? No, Kubernetes and Docker is more hypervising. I see, and all that. What do you recommend? What do I recommend? What for? What is your goal? What are you trying to do? Depends on what you're trying to do. I recommend focusing on one thing instead of 3 things, I guess. Like TypeScript is irrelevant to Kubernetes and Docker. That's like a separate thing. So yeah, and you can, you know. Why can't you just recommend? Well, I just did recommend, right? I recommend you just go into TypeScript and forget about Docker and Kubernetes for now. Just learn programming first and then figure out like Docker and Kubernetes, because that's the next step, I guess, if you need that for whatever you're doing. Do one thing at a time. All right, what am I doing here? We have field expression, name. So this must have a label, right? So instead of saying this is a dot syntax, right? This must be a label dot create a reference in field is t span name, right? Like this. So and then there is no ref label here anymore. Okay, and next there is no label here anymore. What is this? This is expression use dot thing field place expression field. Yeah. So over here, and it's like yeah, and it's like match field with index. I mean, so the only thing that we support here is name, I guess, which has label, right? In this case, we just return this thing. Symbol create label get name label and label match field unbound value field. What do you mean unbound? It's literally over here. Hello? There's no label I use because of this, right? Okay, and then we, if it is index or expression, then we cannot do that. We are going to say placeholder. So error span can must use named field. I just say that belongs into this pattern matcher. I'm playing Bit Burners right now, by the way, feeling so programmer. Deployed Prometheus and Grafana for the sole purpose to get a Discord notification of high resource usage on a single node. Didn't work. I'm gonna build my own solution now. That is the way. Build your own thing. If the existing thing didn't work first try. That's what I do too. Hover specifically. So over here we have a field. So I'm going to, in this case, I'm going to match field with a name label. Then we do that. If it's index, then none, and if it is expression, then also none. Okay. In the common though, now I feel like I need in the place expression field. We have a field, it must not be ignored anymore. I should instead over here do a match field with name, then we don't do anything. Index, then we don't do anything. But if it's expression E, then it should be handler, handle, expression E. Okay. Is this going to work? First try, let's see. Let's see, cast. Let tuple be 1 and 2. So tuple is this thing, tuple.0 is 1, and tuple.1 is 2. Okay, nice. It actually worked. First try. So I can actually parse right now something like tuple 2 plus 2. This should be parsable, right? This should be parsable. Let's see. If I try to calculate this as an AST, then it is parsable, right? So it's a tuple where field is 2 plus 2. Right? But this actually is just not implemented right now, right? To do expression field access. Yeah. But what should this do? Like, this should only be doable, usable for the tuples where all the unnamed fields have the same type, basically, right? That's because otherwise, how do I know the type of this? How do I type check is the question. Here, right? It means that any index which is integer, which means unnamed field, would need the same one. Hello, Brainard. And similarly to that, if we have an expression which evaluates to, I guess, a string, then all the named fields must be the same type. Or something. Or maybe this should be actually like, maybe in this case, if it's an expression, I don't know. Maybe it should be something else. I don't know. We'll see. We just don't support that yet. We only parse it. Am I coding a new language? Yes, I am. I am. So I was just implementing this syntax to get the tuple fields by index. Right? Literally this thing. To have you had similar idea to get tuple fields by index. This already exists. It exists in Rust, for example. You do the same syntax. Maybe in some other languages. I didn't come up with this idea. But we're going to use that to implement arrays, basically, is the idea. So the next one is what I want to implement tuple unpacking. So tuple syntax, you know? That's another one. So what we want is to say that if I have a tuple, which is 1 and 2, right? And then I say something like 0 dot 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 tuple. This should basically expand into 0, 1, and 2. On what scale are you making this? What do you mean scale? What is the what does it mean, the scale? Scale the project. Is that a word to use? Like the scope or whatever, right? How big is the project? Is that what you're asking? Like I don't understand the question. The scope of this project is huge. Yes, I want to support a lot of things. A lot of things come from like a lot of different programming languages, and I'm trying to like unify a bunch of ideas into like my language. So it's supposed to have a lot of features. So the scope is huge. Here we have a website. If you're interested, you can look up there. You can ask some questions. You can see some of the code that I've been writing. I've been solving Advent of Code. I solved 11 days with it, right? But you said you had a similar idea. It means that you're making a programming language yourself. What's your language? Any links? Can we look at it? Maybe I should steal some of the ideas from you. But yeah, tuple unpacking would be really nice. Let me just commit this. Tuple indexing. There's one thing about the tuple indexing though, before we go to the tuple unpacking. I feel like this is still not going to be parsed. Like tuple.0.0, right? Because field is 0.0, right? It's trying to access field, which is a floating point number, which obviously doesn't work, right? So, which is the same bug as Rust had at some point. Tuple is 1 and 2. Tuple 0.1. Failed to parse as member. You're a competitive programmer, would love to use this language. I am also a competitive programmer. Well, I guess not anymore, but I used to be a competitive programmer. I did a lot of it. I was attending the World Finals twice. Didn't really win there, but you know, I was there. Codeforces. Yeah. Well, I mean, like I was doing it when I was studying, so it was mostly like the what do you call it? Like ACM, ICPC, you know, the this stuff. Yeah. Codeforces is I did do it, but I did not do it a lot because we were just doing the local, like what how do you call it, like local trainings, right? Whatever. Yeah. Yeah. I do work at Codeforces though. I don't really speak about it much, but yeah. I cannot solve stuff on Codeforce because I'm admin there right now. I need to do a separate account if I wanted to practice. So yeah, I have not been doing it in a long time, like actually like competing, probably in the last 10 years. Maybe I solved just a couple problems. I was trying to fix tuple.0.0. Congrats on landing a job. No, I'm working there for a long time already. Um. Hmm. Pum 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 pum. What is this? This is the Lexer, right? I need to fix the Lexer, actually, because Lexer needs to know if the previous thing before the number was a dot, so we don't try to look into the next dot, basically, right? Yeah. That's the job of the Lexer here. Um... So we do... We have a read number, right? This thing. So read number needs to read number. Should we allow the dot or not, right? Should we allow the dot or not? Which means that... Okay, where is this used? This is used in a single place over here. So this is the list of rules, right? But it means that my Lexer should basically remember the previous one, right? So my Lexer state is just this. Is just this. I mean, technically, we have reader, which can pick and pick two. Technically, I'm like storing this string right now anyway, but currently in undergrad was interested in coding in a known language. Can you give me some kind of roadmap? There are books about that. I guess maybe you should read a book. I did not read books myself. I don't like reading books, but that's what most people do. Crafting interpreters, this one, I guess, right, is the popular one. Yeah. Recording table. What am I trying to do here? I want to have like the previous... Wait, peaked. This is the token. Yeah. No, this is the token. We just have a reader. So it's like the reader should be able to tell me the previous character, right? So we can pick in front. We can pick two in front. But we can also try to say previous character, right? Reader into char option is going to be reader into string get reader content reader position index -1, like that. So in my parser, in a read number, I just say that scene dot is basically going to be basically reader previous is equal to the dot, right? Like that. That's all. That should fix it. So let's say tuple is 1, 2, and 3. Right, so tuple dot 0 is this, so tuple dot 0 dot 0 is 1 now. Okay, nice. Do you work somewhere? Yeah, I just said that I actually work on Codeforce. But I don't work full-time. You went full time. No, I don't work full time because I want to, like, I literally don't work full time on purpose so that I can spend time working on my projects. Right? So I don't, for that reason. Otherwise, I would not be able to spend this much time streaming, I guess. Bum, bum, bum. Okay, we want tuple unpacking to be implemented now, which means that, once again, if we have tuple 1 and 2, and we say 0 and dot 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 tuple, it should be 0, 1, and 2. Good afternoon. Hello, Okina. Sorry for disturbing. No, it's fine. You can ask more questions if you want. So I'm giving what? Okay, tuple unpacking. So first let's start with the syntax, right? I guess syntax rules. So this is similar to what? This is dot dot dot. This is a little bit higher than the comma. Why is this 499? And this is 5, and this is out of order. I want my things to be in order. Why is this different priority than that one? Okay, whatever. um Let me go get myself a little bit of I need water. 1 second. All right. Syntax. Syntax over here. Syntax over here. Actually, should it be It should be higher than the field in it. What should be the priority here? Let's see. But anyway, syntax, syntax core unpack is going to be priority 5.5. No per associativity, just dot, I guess. That's all. No, hold on. It's dot, the thing to unpack. Should it have the space here? Probably not. That's this. What domain are you into? What do you mean domain? The domain of programming? I'm doing game development, I guess. So that's what I'm into. I'm making my programming language so I can make games with it instead of Rust, which I currently used for game dev. Okay, let's see. So we have syntax 1, 2, dot. So this is not working. Okay, yeah, dot tuple, right? So this is going to be unpacking the tuple here. There we go. Yes. So this is parsable now. This also should be able to do. Yeah, we should also be able to pattern match like that, by the way. But I mean that already is going to work for syntax. We just need to implement the syntax now, right? So core syntax unpack. Actually, wait, hold on. Should unpack even be there? Unpack is basically part of the tuple. On J Blow Path, who is developing his language for 10 years already. Yeah, we just need 9 years more. Also, I heard news that J Blow is going to announce his game today. Is that true? Is that true? Today is something like not game developer conference. There's something today, right? There's something today. Some big fan of Umnik. Don't say hi to him. I have not seen him in years, but we were competing at the same time, I guess. In ICPC. Hold on. What's today? Like today is the thing. Like the Game Awards. The Game Awards. Maybe? Is that today? Today. A little, yeah. I mean, technically it is today, I guess. Right? Live. Wait, live in 3 hours. Yes. I feel like I heard that this is going. It was hinted that he's revealing his game today. But I don't know. That's just a rumor. That's just a rumor. So how do I do tuple unpacking? Let me see. Let me see. How do I do tuple unpacking? Like how would it look like on the expression, right? So we have expression tuple, for example, or type expression tuple or whatever. right? And pattern tuples. Expression tuple. Expression tuple is just a tuple of expressions, right? But now the tuple expression can also contain the unpackings, right? Of some other ones. Of some other tuples. Does that require like row polymorphism for this to be in like for the inference here? Not or not? So like we can say that there is at most one thing to unpack in the end or in the front. Actually, maybe it should, like, the order matters, right? The order matters. Yeah. They shortened PM to P and AM to A, Dice of Cringe. Wait, what? Where? P and P? Oh, wait, wait, I did. Wait, what? Is that normal? Do people do that? How am I supposed to store this tuple unpacking? I can have like the extra unpack here, I guess, but technically, like expression tuple is basically like a list of things which compose a tuple, right? I feel like that's what it is. So instead of having actually a tuple expression, this should be a list of tuple fields, or a list of tuple expansions. Good night, Brainerd. So we have just a list of tuple expression parts. And a tuple expression part is either declaring a field or unpacking a tuple, right? That's it. That is it. That makes sense. And then in order to figure out the type of the tuple expression, we need to like infer the types of all the parts. Which makes sense. Makes sense. Okay. Yeah, I mean, yeah, that's pretty easy actually. But we will need to redo these things here, right? So expression tuple actually has parts, which is expression tuple part. And expression tuple part is going to be either a field of expression tuple field of, or it is an unpack of expression, right? So we just unpack an expression, or we declare a field. Or we declare a field, and this has a label which it actually should be optional. Which actually should be optional. In this case, I'm making right now fake labels for like zeros. And I should not be doing that. So I think that tuple part of could also be generic, and then this over here is not necessarily an expression. This. Which means that I can like unpack a pattern, basically. Right? So I will be able to write code like this, where let x dot 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 y that's going to be, yeah, that's how we would store it. And then this can be any pattern, so I can say dot 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 like y and z to be equal to 1, 2, and 3, right? So this is technically correct because we are unpacking y and z, which basically gets us x, y, z, and yeah, that's technically. I don't know why would you want to write it like this though, but yeah. Why not? But we can also like assign basically the rest to the tuple, and then the rest will be just 2 and 3 in patterns, right? Yeah. Okay. And then assignee tuple, assignee. Oh my god, why do I need to copy paste things here? Camel. Everything is red now. Anyway, so we have an expression, right? I did it with expressions. Then I need let's see, we need all the other things. So we have expression. Then we have a place expression. There is no place expression tuple though. Yo, Brooks Orker, hello, hello. Why is there no alert for the raid? But welcome. Oh, there it is. Why is there no sound for the alert? Why do I see it, but there is no sound? Weird. I think I saw your stream title. You were like making your own shell. Is that right? How's the progress? So I'm making here my own programming language, and I'm right now trying to implement tuple unpacking, or I mean unpacking. So if you are familiar with Rust, because that's what you are doing, I guess, right? Then then in Rust you can say that like if you have struct foo, which has like field A, field B, and field C, right? You say I32 in Rust, that's right. So you can say foo is foo A1, B2, C3, and then you can say that let foo is foo, where A is like 5 and dot foo, right? So we're implementing this syntax. But I'm trying to do it in a more general way. So I want to allow this to be in any position. And for this to work for tuples, trying to fun with the challenge test and autocomplete, you're following a code challenge. Is there a code challenge to write your own shell? Is there a competition for shell developers? So yeah, we're doing this. Well, so I'm doing this more generally, just like for tuples, so that we can have a tuple like 1 and 2, and then I should be able like to say tuple squared. Basically, I should be able to write like tuple and tuple, and this will be a tuple of 1, 2, and 1, 2, I guess, in this case. And I should be able to do pattern matching similarly and like other things. Let's Code Crafters. You partner with them? Oh, I see. Nice. Nice. Yeah, I remember code crafters. You implement your own thing. Code crafters. I looked at that at some point. Advanced programming challenges. It's just for learning, right? Or like it's not competitive, right? Build shell from scratch. You're doing this thing. Rust beginner. Free this month. Right. Nice. All right, let me get back to my thing. So I need to change my structure of code here so that we support unpacking. This expression, place expressions don't have tuples. They don't. They make no sense. But assign expressions can be tuple. So assign expression tuple is going to be parts, which is assign expression tuple part tuple x. Maybe I should call this tuple it's okay. Tuple part of, sure. Tuple part of. So we have a assign expression type expression tuple should be the same. Expression no, tuple part of. And then we have patterns, and patterns should also, pattern tuple should also support that. Pattern tuple part of, wait, tuple part of the list, right? So this is like the list parts. That's what we want. Type expression tuple, this is going to be parts, which is type expression tuple part of list. Parts, this list. Yeah, thanks you for the raid again. Having good rest. It seems like this feature that I'm doing right now is actually going to take a while. Maybe I should not have started it today. Maybe I should not have. Expression tuple is parts expression. Tuple par expression. Tuple part of list. Right? This. I should just, you know what? I should just call it a tuple of, you know? And tuple of A is parts is a tuple part of a list. There we go. So expression tuple is expression tuple of, basically. And, oh my god, this is so annoying. Okay, assignee expression tuple is assignee expression tuple of. Type expression tuple is type expression tuple of. Pattern tuple is pattern tuple of. Okay, now I can copy paste, right? And this over here. I'll have copy pasting. Okay. Now we follow the compilation errors. When I'm printing tuple, tuple, I kind of want to say print tuple fmt by printing expression. Print expression. Can I rename this without a camel? Let's just remove this. Print expression options. Just inline that stuff here. Well, I mean, actually, yeah, whatever. And print tuple is for all A. If I have A, tuple of, and I have a formatter, then I can print it if I know how to print A, right? So A formatter A unit, like that, I guess. Function print A empty tuple, which is having parts. So I'm just going to say list print fprintf fmt tuple %a list print parts list print tuple part print A and print your tuple part A formatter A unit into formatter into a tuple part of this function print A fmt into function. So if it is, so we have the parts, which is a field. Field, right? That I say print tuple field. Tuple field print A fmt field. Okay, and if it is unpack, A, then we say fprintf fmt %a print AA. And print tuple field of is going to be function print A fmt what does the field have? So we have label and we have field, right? Yeah, I guess I need a label here. Or, I mean, yeah, I guess it must be a label. So right now I don't support expressions in label positions. Just say label and whatever. Is there a label print? There is, right? Yeah, so I can do label print. Yeah. So label is equal to this thing. To label. And what is it equal to? Well, it's just, yes. We also have the field. Label span. Or is it called field span? Option print. I'm going to match label with some label, then we print it. If it's none, then we just print a FMT field. And in this case, we just do print label and then print a field. Expression tuple print expression. FMT goes here, right? So just when I'm printing the tuple, it also needs to, I need to like change this symbol, right? And to change that symbol, so in this case I use equal print ir tuple. So this is going to be character also. So this is the equal sign bar equal sign bar equal sign C equal, so that I can actually configure it. Hold on, let me, you know what, actually let me end the stream. I feel like I need to go right now. Might finish this tuple unpacking off stream. So you know, let's just go somewhere else. Let's see Advent of Code in Haskell over here.
Voor maar 9,95.
Maybe. They just started solving the Advent of Code here. Day 11, I guess. So yeah, see you guys next time. Bye.